Yeah, so Boeing is one of those companies where people think they already know the story, like something went wrong, someone cut corners, safety stopped mattering, end of story. And honestly, that's kind of what we assumed at first too. But the more we started looking into it, the stranger it got. Because there wasn't this one big moment where everything snapped. There wasn't a single decision where you can point and say, that's it. That's where it all went wrong. Nothing actually broke. And that's the part that takes a second to sink in. The airplanes didn't suddenly start behaving randomly. The engineering process didn't collapse overnight. The system didn't just fail. What really happened was quieter than that. For a long time, Boeing wasn't just a company. It was almost like an engineering institution. Engineers weren't just involved in decisions, they had authority. Real authority. If something didn't feel right, things stopped. If a test failed, timelines slipped. If a system behaved in a way that didn't make sense, it got redesigned. Nobody was rushing to justify it or explain it away. And yeah, that made things slow. It made projects expensive. Airlines complained, executives worried about margins. But it created something incredibly valuable, which was trust. For decades, Boeing planes weren't just aircraft. They were assumptions. The assumption that safety came first. That engineers always had the final say. That if something could fail, it had already been thought through. And those assumptions weren't marketing. They were earned. Slowly, over decades of conservative design and relentless testing. Passengers didn't really think about Boeing at all. And that was the point. When engineering works, you don't notice it. But cultures don't collapse overnight. They shift. And when we traced Boeing's internal priorities over time, you can see that shift happening. Competition starts getting more intense. Global air travel explodes. Costs rise. Fuel efficiency becomes a selling point instead of a bonus. Then you get new manufacturers entering the market. Suddenly, delivery timelines matter in a way they never did before. Being late isn't just inconvenient, it's strategic. At the same time, financial pressure ramps up. Wall Street wants efficiency, markets reward speed, delays stop being tolerated. Missing a delivery date doesn't just mean an angry customer. It means lost contracts, lost confidence, lost market share. So priorities start to change. Not all at once, not maliciously, just gradually. Engineering still matters, but it's not leading anymore. And that's a subtle shift, but it's a huge one. Because once efficiency becomes measurable and speed becomes rewarded, decisions start passing through financial filters before technical ones. Deadlines start carrying more weight than internal objections. Milestones get tracked more closely than risk assessments. Not because safety stopped mattering, but because safety was assumed. And that's where things start getting dangerous. Because once safety becomes an assumption, it stops getting questioned. The pressure really comes to a head when Airbus introduces a competing aircraft. Lower fuel costs, higher efficiency, faster delivery. For airlines, the math is simple. Lower operating costs mean higher margins. Faster delivery means faster expansion, so airlines start paying attention. Some quietly signal they're willing to switch manufacturers. Others make it clear that loyalty now depends on timelines, not history. From Boeing's perspective, the message is obvious. Move fast or lose dominance. And that forces a defining decision. Do you design a brand new aircraft from scratch, which takes years and costs billions and forces airlines to retrain pilots? Or do you adapt an existing platform and move faster? Pilot retraining alone is expensive and disruptive. Airlines hate it, regulators scrutinize it, schedules blow up, so adapting an existing aircraft looks reasonable. It keeps pilot familiarity. It shortens certification timelines. It reduces the risk of customers leaving. On paper, it makes sense, but in practice, it introduced a different kind of risk. When we looked closely at how the aircraft was modified, a pattern shows up. Instead of redesigning the airframe to accommodate changes, software is used to compensate. Physical tendencies are managed digitally. Behavior gets corrected in real time. That saves time. A lot of time. But it also means the system has to work exactly as intended. There's less margin for error. Fewer opportunities for human correction, and at the same time, the certification process itself is evolving. Regulators rely more heavily on manufacturer data. Delegated authority expands. Review timelines tighten. This isn't negligence, it's efficiency. But efficiency only works when incentives are aligned. And when competition intensifies and timelines compress, small compromises start stacking up. Not in one meeting, not in one decision, but across dozens of reasonable choices that together reshape outcomes. Inside Boeing, concerns do surface. Engineering teams flag edge cases. Test pilots report unexpected behavior. Internal conversations get tense. Questions come up about system dependencies, about pilot awareness, about how much the system should be doing on its own. But by that point, the timeline is locked. Contracts are signed, deliveries are promised, public commitments have been made, and once a program reaches that stage, technical objections aren't competing with ideas, they're competing with momentum. Momentum usually wins, so when problems start appearing, they don't show up as one big failure. They show up as patterns, unexpected system behavior, conflicting sensor data, responses that don't line up with pilot expectations, and each incident raises the same quiet question. How did this get through? This is where the story really changes, because the more we looked at it, the clearer it became that nothing actually broke. The airplane didn't behave randomly. The process didn't suddenly collapse. The system worked exactly the way it had been redesigned to work. For decades, the people closest to the risk had the loudest voice. Engineers, test pilots, the people who felt the consequences first. If they said, "This isn't ready," everything stopped. Over time, that changed. Not all at once. Not because anyone was evil or reckless. Decisions didn't disappear. They moved. Away from the people closest to the risk and toward the people farthest from it. Timelines started carrying more weight than hesitation. Commitments mattered more than objections. So when risks appeared, they weren't ignored. They were managed. And managing risk feels responsible. Until you realize you're stacking assumptions on top of assumptions. That's the real story. Boeing didn't suddenly stop caring about safety. It slowly stopped letting the most cautious voices decide. And once that happens, the outcome isn't shocking. It's predictable. This is the part that almost never makes headlines. When incidents happen, pilots don't argue about brands. They don't debate loyalty. They don't panic. They ask operational questions. What failed? How is it supposed to behave? And what does this mean for the next flight? In pilot group chats and private conversations, the focus isn't fear. It's predictability. Because pilots don't fly airplanes blindly. They fly systems. They care about how an aircraft communicates, how it responds under stress, and whether its behavior matches training. That's why a lot of the conversations weren't about whether Boeing aircraft were safe. They were about expectation gaps, what the aircraft did versus what pilots were trained to expect. In older designs, pilots were clearly in charge. Automation helped, but it didn't override. As software took on a larger role, that balance shifted, and pilots noticed. Privately, the concern wasn't panic, it was complexity. More layers, more logic, more moments where understanding why something happened mattered just as much as reacting. One idea keeps coming up: awareness. Pilots don't just need systems that work, they need systems that explain themselves. Because when an aircraft does something unexpected, even if it's technically correct, it creates hesitation, and hesitation in aviation matters. That's why the conversation shifts away from individual incidents and toward design philosophy. How much authority should software have? When should it intervene? And when should it step back? These aren't emotional debates. They're operational ones. And they're the kinds of conversations pilots have with each other long before the public hears about them. As investigations continue, another pattern becomes obvious. These aren't isolated mistakes. They're systemic. They're the result of incentives that reward speed, a culture that assumes safety, and processes that trust redundancy without fully testing how systems interact. Responsibility gets spread across teams. Decisions get diffused across layers. No single moment explains everything. Together, they explain a lot. What follows is unprecedented scrutiny. Internal documents become public. Testimony gets taken. Design decisions get reviewed line by line. Emails are examined. Processes are questioned. Assumptions are challenged. For the first time, Boeing isn't just answering to regulators, it's answering to the world. Financial penalties come next, but that's not the real cost. The real cost is credibility. A company that was trusted by default is now questioned constantly. Every delay raises suspicion. Every incident makes headlines. Every whistleblower adds doubt. Trust that took generations to build erodes in real time. Even now, Boeing operates under intense oversight. Aircraft are still delivered. Flights still operate safely. Regulatory scrutiny is stricter than ever. Reviews are deeper. Certifications are tougher. Margins for error are smaller. But the relationship has changed. Trust isn't automatic anymore. It has to be earned, again. And here's where the story shifts one last time. Despite everything you've heard, modern Boeing aircraft are still among the safest machines humans have ever built. That's not opinion, that's data. Aviation safety today is systemic. It doesn't depend on one company, one engineer, or one decision. It depends on layers, redundancy, independent oversight, global data sharing. When failures happen, they're investigated publicly, corrected aggressively, and redesigned permanently. Lessons are shared across manufacturers. Standards evolve globally. That's why aviation safety keeps improving. That's why flying today is safer than at any other point in history. So Boeing didn't suddenly become unsafe, it became visible. The system worked, but the illusion disappeared. And when illusions disappear, confidence takes time to rebuild. The real damage wasn't mainly to passengers, it was to belief. Belief that engineering always led. Belief that incentives aligned with safety. Belief that speed would never outrun caution. Rebuilding aircraft is hard. Rebuilding trust is harder. And rebuilding belief takes the longest. That's the part still unfolding.